Show you a little application I wrote. This is a very simple but complicated application for what it's going to do. It's also the best looking application I can ever write. It's just black and white with Bootstrap, it's just text. But it does use the microservices architecture behind the scenes. Whether you should be doing this or not, that's another discussion. But in case you're using microservices, right, this is what you would end up with. And what this app does is you press a button, you say your name and message, you press a button. It's going to call a service that says hello to you, and it's going to give you, basically save the data into MySQL, okay? So there's another service behind the scenes. High-level architecture, it looks like that. There's the front-end UI, and then there are the two services behind the scenes. They're all running in containers, and they're all being run inside of Kubernetes, right? So this is using Kubernetes as orchestration. And also we deploy MySQL and Redis into the same cluster. And with a single command line, we are able to basically start this whole thing, and we should be able to take a look. So I'm running this in Google Cloud Platform inside of Container Engine, or now they call it Kubernetes Engine. Basically, with a single click of a button, you just say how many instances of the Kubernetes cluster nodes that you want. And you got here, I got 5 nodes. So in this cluster, I have 5 VM instances that's running Kubernetes, that's being controlled by Kubernetes. And I already deployed many of the applications. Basically, for every app I'm going to deploy, I need to create a little descriptor, okay? So the descriptor looks like something like this. It basically says, you know, the application is called guestbook, and I'm deploying this container image that is stored in a registry somewhere. And I can also specify the readiness probe and health checks so that I can check whether this application is alive. If it is not alive, then we can actually restart the application for you. Moreover, we can also say how many instances we want to run. So in this case, we're running 2 instances of each of the services. Okay. In addition to that, we also expose the load balancer, because if you have 2 instances of your app running, well, how do you connect to it? Well, in Kubernetes, we can also expose it as a service. Basically, what that means is it's going to create a L4 load balancer. This is a network load balancer. And so this load balancer will create like an IP address that's going to listen on port 8080, and it's going to be forwarding to each of the instances on port 8080 as well. And so here's the app. Let me see here. I got my internet. That's good. And you can see I got my Hello World service running here. I got 2 instances running as well. You can see that they're clearly running on different VM nodes as well, because I got 5 nodes. If I scroll down, you can see these lines. That's basically indicating who they are talking to. So the Hello World UI is talking to guestbook service, and so on and so forth, right? And these green boxes, they're just a load balancer. So we can basically just go take a look. Right, so we can see that the application started. We got a little Spring logo here, so that's good. So everything should be up and running. Huh. Interesting. Let me, So as you in the audience, this is probably the moment that you've been waiting for, to see the speaker fail miserably in the demo. And I think you cannot fail any worse than this, because I actually have no backup. Those of you who see my talks, I have absolutely no backup, so there's no way I have no video. But let's take a look at here. What do I have here? So we have one of the worst error messages ever. We have the internal server error with 500. And then we got a 404 in the same page, and a null pointer exception, of course, because it's a Java application. And there's not so much we can do here, right? It just doesn't work. But that's okay. I do actually have a staging environment, luckily, right? So what we can do is let's check staging, right? Maybe staging works, right? So in this case, I have a little backup, but it's not exactly what I wanted to show you. So let's check staging. In Kubernetes, we can actually carve up the entire cluster into different namespaces. Okay, and within a namespace, you can actually say how much resource you can allocate to the namespace. For example, if you have a cluster of 5 machines with, 60 cores in total, you can say staging namespace can only use 10 of the CPUs, but not all of them. And you can also deploy exactly the same application into staging. So for example, I can do something like kubectl apply. This will help me deploy everything. That means I want to deploy all of the files in this YAML file into my staging environment, right? So I can say kubectl apply-f dot, which means send all of the files into staging. No, kubectl apply f. Oh, I need a little space here. And with internet, which looks okay, I can just deploy everything into my staging environment without having to change my application. Because internally, within the namespace, all the names, all the individual service names, they can be exactly the same. Okay, so I can also go and see if I can get my staging up and running. So I have staging, okay, and I can see my load balancer here, and I have the front-end application. So that's the staging IP. So the production IP ends in 97, and the staging IP is ending in 52. And let's go take a look. Ah, yeah, it works. So I can say something like Ray, hello, DevOps, Morocco, and if everything is connected up with the database and all that, it works. I guess it does work in staging, but I'm having a little issue here in production. But of course it works in staging, right? Everything works in staging. Why would you go to production if it didn't work in staging? So checking staging environment is good when this happens, but it doesn't necessarily mean you're going to find the issue. However, one of the things we do need to check is to see whether they are actually running exactly the same application, right? And so what do we actually deploy here? I deploy the containers, right? So in containers, you have the coordinate to the container and potentially the version of the container that you're trying to deploy. So for example, if I look at my Hello UI deployment, so I'm going to open up my UI deployment here. And if I scroll down, I should be able to see the image I'm going to try to deploy. And this is the image I'm trying to deploy. What is wrong with that? Latest, that's right. It is deploying the latest version of something. And somebody might say, well, of course that works. We're doing continuous integration and continuous delivery. You always deploy the latest. However, the problem here is latest on my machine could be different from the latest on your machine. It depends on when you actually pull the latest version. If you build the application today, that's the latest for today. But if I haven't built the same application for a month ago, that's the latest version on my machine. So there's very possible I have pushed a different version of my container to my Kubernetes cluster, right? So the only way for you to make sure, well, number one is never use the tag latest. And you should always make sure the tag is not being reused. You need to version your containers. But the only way that you can actually make sure is by actually looking into the container to see exactly what's being deployed. In Kubernetes, the really easy way for you to do this is by using the describe command. And you can say describe my instance. You can give it the specific instance you want to look at. So I'm going to look at my production environment. And in my production environment, we can clearly see that the image is latest. You can also see other things like other configurations. But more importantly, you can actually see the SHA. This is the hash for the container itself. So in order for me to make sure we are using the same container images, I need to check this hash and see what that actually is. So this hash ends with 73E, and I can do similar things. I can get my pods, get my instances from staging, and let's see if they're running exactly the same thing. Okay? So I can do something like and staging and describe the instance, and let's see if they're actually running the same thing. So I'm looking at staging. Of course, it is latest, but you can see here the last 3 digits at the very least is the same. So at this moment, I'm pretty sure they are the same application. But what is actually inside of this container? Anyone knows? Well, you don't know, I don't know. Yeah, right? So you need visibilities into potentially what is inside the container. Now, you might be doing this while you're troubleshooting or not, but when something actually happens, you really need to know what's running inside. Well, what do? You can pull down the container and see what's inside, or if you're using some kind of tool that's helping you to build and also store your container images, then you can potentially ask these tools what's actually there. Because I'm actually running everything in Artifactory, that's actually I'm running in the hosted version. Baru gave me the instance, And if I log in, what I can actually do is I can go and search. I can actually use the checksum of the container hash, and I can do a search. And from there, I can actually see what that latest version is. In this case, I can very clearly see that this latest version refers to version 50, right? And if I go into it, I can, of course, get more information about where this version 50 came about. I can see my Docker info. I can see what is running. And what is running there is app.jar. Now, this is something that a lot of people do, is they just copy it into app.jar. In fact, all of my containers, if I go to my guestbook service, if I go and see, for example, where did it go? My container, and guess what? Guess what is running? It's also running app.jar, right? And that is not very effective. What you actually need to do is to kind of figure out, you should name it properly. And if you don't have the right tooling, if you didn't do it properly in the first time, then you should probably, use your tools to kind of figure it out, okay? And from here, what you can also do is potentially trace back to the Jenkins build, right? Because they record all of these metadata. You can actually go back to the Jenkins build and see what's actually produced in your container. But in this case, I'm pretty sure this is the container I'm supposed to run. I mean, I can try other images, but I'm pretty sure this is the one. Then what do you do? For the record, this is still not working. What do you do next? Anyone? This is not a very effective error message. So the next thing that you might do is you check the logs. Very good. So you make sure this is working. You make sure this is the same version as staging, which you tested. Of course, I tested it. But then we still need to understand what's happening. Then we need to check the logs. Now in Kubernetes, the thing here with containers is you shouldn't write any log messages to your file system. What you should be doing is to always write your logs to std out. Just send it to the output or std arrow streams. Because if you do it that way, in Kubernetes, rather than having to log into the machine and find the container that you need to look at, or find the files that has the log, in Kubernetes, you can just give it the name of the application instance with the logs, and now you can tell it. Now you can just tell the logs, which is really, really easy to do. Now, however, we only have 2 instances here, which makes it a little easy. What are the odds for me to find the log in the first try? It's like 0%, 50%, 50%, right? But what if you have a production system that does that, right? What if you have 10 instances now? What do you do? It's still 0%, right? No, as Baruch, as my co-speaker who's not here right now, he's going to tell you, even with 10 instances, the odds of you finding the log is still 50-50. It's either you find it or you don't, which is not exactly the right math, right? But in this case, you could actually see the logs, but you have to figure out which of these instances actually have it. It's not guaranteed you're going to get this on the first try. So there are some tools you can use to help you. The first tool, which is really nice, is open source tool called Stern. With Stern, you can say hello world UI, right? I can actually give it the name of the application. If I do it this way, this will actually go ask Kubernetes all the running instances and stream all the logs to me. Okay? So with this running, I can do a refresh and I can see my log immediately, right? And you don't have to guess which instance actually has the error message. However, in a production system, this is not gonna be very helpful, because if you have, say, 20, 100 or 1,000 requests per second, this is not gonna help, right? It's 3 a.m. in the morning, and you don't have the time to look at 1,000 QPS and try to figure out what is wrong. So in Kubernetes, what we can also do is, because the log is outputted to the std out, there is actually a log pipeline that you can create that captures all of the logs in either via FluentD or other tools, or if you install like a Elk Stack, Elasticsearch, Logstash, and Kibana, we can actually combine all of these log messages into centralized logging. And from there, then you can go in and you can see the histories of the logs. You can actually ask meaningful questions. Okay? So in Kubernetes clusters, you definitely just want to install some kind of centralized logger. On Google Cloud, because I created this cluster on Google Cloud Platform, we have a centralized logger that's pre-installed for you already. like I said, you can pick and choose what you want to do, but by default, you get this out of the box basically for free, right? So here I have a centralized logger that is doing what it needs to do. It's capturing all of the std outs and std errors. And what that means is, if you want to debug something or figure out what's wrong, rather than SSH into the machines and copy all the logs out and doing grep or trying to do a Perl script to search for things, well, you can just go ahead and find the cluster that you want to see, which environment do you want to check, and then potentially even which application that you want to look at, right? And you can even drill down to the particular instance, and here you can see all of the logs that's coming out from the Kubernetes instances. And of course, you should be able to do a search. Did I type it wrong? No, exception. And I can just zoom in and I can see the exception here. Now I can get a lot more info in a more reasonable way. And I can see that this is client error exception 404 null. Of course, it's a null pointer somewhere. There are some things I can probably get all of it. Okay. However, I remember during the days of my when I'm doing everything for a hospitality company, like a hotel chain. When the hotel chain's website goes down, they're going to lose a lot of money because they cannot take any bookings anymore. So when that happens in the middle of the night, I get called up. And the first thing that I do is, I try to copy the logs out because we didn't have centralized logger. I try to see how often is the exception happening. Is this happening across the board on every single machine? Or is it happening with just one instance? Because 3 in the morning, if it's happening to all of the machines, I know I'm not going to go to sleep. If it's only happening to one instance, what do? Anyone? You kill it. Well, yes and no. We're going to see why and why not. Okay? But in this case, I like to ask more questions. So once you have data in a centralized logger, you could potentially do more analysis. In this particular case, we can stream things into a messaging system, like pops up. Then you can do near real-time analysis of all the log entries that you're interested in. Or you can store things in long-term storage. But my favorite is actually this one. It's called BigQuery. Within Google, we have an internal system called Dremel. Dremel is a system which you can use to query data, structured data, with terabytes or petabytes of data with no indices. Okay? And we actually use Dremel to be able to do some of these analysis on logs as well. I personally wrote queries that took 20 minutes to run, but I don't know how much data that was there, right? But typically in BigQuery, we can go through about 200 gigabytes in about 10 seconds or so with regular queries. So what we can do, because I already have the pipeline set up, what we can actually do is to ask these meaningful questions if I ever want to figure out what's in the logs. So I'm going to open the query that I wrote already. So this is just standard SQL. I wrote it on the top. This is standard SQL. So from the logs, which are exported into BigQuery in this case, I can see Hello World UI logs, for example. I can see the tables. I can see all the fields I can actually query. So with a system like this, what you can do is to ask meaningful questions. So one of the questions I'm going to ask is, well, count the number of exceptions that's happening in a container that has the prefix of Hello World UI, which is my application, right? And from which day? Well, I can say from one of the days. Which one is today? That one. I can say from today, or I can say from every single day. Okay. So, or I can write a query to limit it. I'm going to group by the name. I'm going to order by occurrences. I'm going to basically see the count. So what this will be able to tell me is, for example, is this error happening in just one instance, or is it, fairly distributed across all of the instances? This is one of the ways that you can tell. Of course, there are other ways. Let me just go back there and see if this is still working. No luck, right? So assuming this is just one instance that's happening, that's having trouble, well, let's go back and see, right? So if I do a kubectl get pods, this is going to tell me all the instances, and this particular instance has most of the errors, 47 HZ9. Do I have it? Yeah, I have it here. Yeah, I have it here. Now, of course, we can kill it, just like somebody tells me that they restart their JVM every week, just so they don't have out-of-memory issues every week. Yeah, somebody's like nodding their head, right? Do you actually do it? Yeah. Please. Yeah. You should talk to him. Right? So the problem is with this is that if you just kill it, you don't know when it's gonna have the same issue again. If you just kill it, you cannot be sure if this is actually causing all the problems. So yeah, there you go, right? So for me, I don't necessarily have to kill this right now. If I want to kill, I'm not killing anything today. But if I have to do it, I can say delete pod is going to kill this instance and automatically restart another one. But we can do better. In Kubernetes, the way that we route the traffic is by using something called labels, okay? So with the front-end application, if I scroll down a little bit, I give it labels. Labels are just key value pairs that's attached to your application, for example. And this label, this application has the label of app and the name of the app, and also the version which is running latest. But we also added a label myself called serving, okay? What that means is when the load balancer is trying to determine how and what applications instances to route to, it's actually using the labels to determine this. So what that means is this load balancer is only routing traffic to the applications called Hello World UI, and also with the label of serving is equal to true. What that also means is if I feel that this particular instance is having all the issue, well, guess what? Rather than killing it, I can basically update the label. I can override this label, okay? And I can set it to false, okay? And what that's going to do is basically take this container offline, isolate it, and now you can actually interrogate what is actually happening there, okay? So let me just show you the label again. So for example, I can show you the apps and serving labels if I zoom out a little bit, right? Here we have the UIs, and I set this label to false, and now this particular instance is being isolated. This is not being served anymore, okay? But if you actually count the number of UIs, we still have 10 in total, right? Because earlier I said, Kubernetes, give me 10 instances. And now I took one out of the service, so Kubernetes will automatically restart another one for me, right? So we still have 10 instances running, it restarted another one to take over, and that's this one that's being started that's about 16 seconds ago, okay?
Maybe it works now.
Yeah, maybe it works now. Let's take a look. Let me go and do a refresh. No, still not the case. But, right, we need to know in this case whether this particular instance is causing the issue. How do I do that? Well, a couple of things. I can use Kubernetes. I can go into this instance. I can go in Docker. You can do Docker exec, right? Or if you're running a VM, you need to know, which machine it's running on. You SSH into it. In Kubernetes, you can just do kubectl exec, the name of the instance, and what command line you want to run, and that will drop you directly into the shell. And then you can do a PS, right? You can see this application running. If you actually wrote, which you're not supposed to, but if you wrote logs into the file system, you can see the logs. You can also optionally not kill with the -9, but in Java, you could kill it with -3. I believe that's going to cause a thread dump, so you can get more information out of it. But we can do even more. If you want to just test out whether this instance is working or not, we can actually pull forward from your local instance, from my laptop, and establish basically a secure connection into this remote container instance without you ever having to SSH into the machine. This is quite neat, right? So I can say, I want to forward from my local port 9090 into the remote port 8080, okay? What's that? I'm sorry? Yes, yeah, you do need the sufficient privileges to do that, yeah. But out of the box, as an admin, you probably get a lot of privileges already, but you can lock it down with RBAC, for example. But in this case, I just opened up my tunnel, 9090. I'm opening up to 8080, okay? So I can see very clearly through the load balancer, this is not working. But if I go to my local host 9090, let's see if that works, 9090. Well, that actually works. So I can say, Ray, hello from production. So we know that this instance is not the issue. The issue is elsewhere. This instance was actually good, even though from our query, it may have seen that this instance is bad, but this is actually not bad. Right? Now we have a choice, like, okay, that's great. We can also, like, if you're running GMX, right, if you want to connect to the GMX port, you can also establish the tunnel here, then you can connect to this specific GMX instance as well. But now we're saying that, wait a second, this instance is actually good, right? This is actually a good instance. Now we have a choice. We can either kill it, right, or we can actually try to put it back into service. And if we want to try to put it back into service, you just modify the label and set serving is true. However, because we set into Kubernetes, we only want 10 instances running. If you put one back, you're going to get 11. Then what happens? Well, Kubernetes will have to decide and kill one of the instances anyways. Okay? And there's a heuristic on how Kubernetes decides what to remove. It typically tries to keep the longest running instances that's healthy around. It tries to remove the ones that's unhealthy first. And if everything is healthy, it tries to remove the one that has the least runtime. Partially because the ones that has been running longer is probably the most stable and also most warm up. If you have something that just got started, it's kind of okay to just get rid of it, right? So I put it back to service. Now we still only have 10 instances. And we can go back to the application. User wouldn't feel a thing. For me, it's still not working. Yeah. But we're gonna find out pretty quickly why. But because I mentioned this is a microservices deployment, right? So we know, like, okay, everything seems to be working for that one instance, but could anything else be wrong? What else could be wrong in this case? Well, in this view, I'm telling you that the UI service clearly communicates with guestbook, which clearly communicates with MySQL and so on and so forth. Do you actually trust this view? Do you trust it? Well, it depends. It depends on how this view is being created. If I told you that I hard-coded these lines, would you then trust it? No. Why? Why not? Because it is now a documentation. So I'll tell you the truth. In my deployment file, I did hard-code these lines. I said to the visualizer that this application is using these applications. But are they actually using it? How many people have this happen to them where you said, oh, let me troubleshoot this, let me go check out the documentation. And after 4 hours, or maybe a whole day, you realize, the documentation is outdated, right? In a microservices deployment, I can guarantee you that this is gonna happen more and more. What you really need is the real-time insight and observability into your architecture. And within Kubernetes, there are a few things that you can do. Well, first of all, there's a really, really nice tool called Weave, or Weave Scope. And what that's going to do is to introspect connections in real time. So what Weave Scope can do, if I can get connected, is to actually show you exactly which applications is establishing a connection to another application, right? So you can clearly see these two lines is not there right now. So maybe there's a communication issue, right? You can see that these are established, so you know that the connection is going through, and so on and so forth, right? So you can use Weave Scope potentially to kind of troubleshoot and see what is going on in your cluster. But really, for a distributed system, what you really need is distributed tracing, potentially, to see cross-boundary communication. Okay? And I actually am using this. I have Zipkin set up. So Zipkin, you can actually see, you can forward these trace requests to Zipkin, and we can see what's going on for the service code. So maybe there was something wrong with my service code here, which I don't know, right? So I'm running Zipkin. You can run your own Zipkin, or you can run a Zipkin proxy that forwards the data. In this case, I'm gonna forward the data to my cloud as well, because I don't want to manage my own Zipkin instance. I mean, you can if you want to. If you don't want to, then you can go and check this out. So you can run the Zipkin server that forwards the data to my trace. In this case, this is the managed service. Okay, so I can check out my trace. Because we have all the trace information, we can also build a latency distribution graph for you. Okay, And because we have the data, we can also build reports between different versions of your applications. But more importantly, I should be able to see my trace data. Oh, somebody's being DDoSing me a little bit earlier, right? So I can go ahead and see my trace. Right? I can pick one of these things. I can see that this request went through. It was retrieving the messages and so on and so forth. I wonder if they have a trace of the failure. So what I can do is I can actually go and find 100 errors, for example. Because I'm forwarding the data to my trace, I can do analysis here. And I can see, there we go. We have here the application now returned 100 error. Okay, I can see where this happened and why. But more importantly, that's interesting. It made the call to hello, but there's a 404. Yeah. Okay, so this call potentially have failed. This call in my microservices chain of calls, this one specifically has failed. But I'm not quite sure why this failed just yet, right? I know it failed, but I'm not quite sure why. Then what do you do? What do you do if you just cannot be sure what happened? You may actually need more log messages, right? And how do you get more log messages? Anyone? Huh? You gotta check out the right code, right? You have to potentially go back to your Git repository. You gotta check out the production code, and then you add the log messages that you want, right? Hopefully you'll find the issue, and then then you redeploy it. Hopefully you can do the redeployment really quickly, right? Sometimes it takes hours to do the redeployment. And then what? If you don't find the right logs still, what do you do? Huh? You debug. Yeah. You debug it. No, but you can't debug it. If you debug in your production system, what happens? You gotta stop the world. And then somebody has to be there, click through the whole thing all the time. We can actually do better. Earlier, when I showed you the Artifactory stuff, right? You actually saw what was running inside. I'm gonna go back there and I'll show you what's running inside, right? This still doesn't work clearly. And if I go to my builds, maybe I go to my root pipeline and let me go in here and let me find my modules. If I go into my container, what I want to show you is the startup command lines. If I can actually find it for you. Can I find it? No, I can't. Yeah, I don't know Artifactory as much as I should, but I'll show you what was actually running inside, right? So if I go to my examples.java, if I go to my hello world UI, if I see the Docker file, here's what's running inside. In addition to the application jar itself, I actually attached a real debugger that can actually work in a production-like environment, or actually production environment. I shouldn't say like. I can run this in a production environment. This is actually the same debugger agent that Google uses in the production system. Okay, so we use the debugger on our applications for our production workload. You can use this basically the similar or the same agent in your workload as well. What that's going to get you potentially is this. I can go to my Debug Console in this case. Or if you don't want to do this on the browser, you can also do this from the command line. And I actually have uploaded my source code into Google Cloud. Okay, that's just the thing I chose to do. But it's actually going to be able to check out the right revision of your source code. So what I've done is I use Git properties. I use the Git commit plugin. It generates the Git.properties file, which also records which repository and what revision I'm trying to I've built. So this actually shows you the current revision that's running in the production environment. Okay, so I got this hello UI. What I can actually do is I can go into my controller. I can zoom in a little bit, if I can do that. I'm gonna remove some of these things for now because they are not applicable right now. Come on now. Do I do zoom out and delete? There we go. I can do two things. Number one is if I want to add more log messages, rather than what I just described about checking out the code, redeploy, you can literally just click on here and say I'm here. That's how we debug in Java, right? Because number one, I'm here. And you can say, add another one to I'm here also, right? The moment I do this log instruction, this log message, will be propagated to all of the running instances that's attached with the debugger. Okay. In fact, I can do even more. I'm wondering what the name was, so I can say the name is, I can even give it the expression. I can see whatever that's in scope, so I can say, let me see the name. Okay. And now I can go back to my app, another log that comes in, and where do we see the logs? You got it. We can go to the logging console, right? Go to your centralized logger, and let me just find mine. And if this actually works, we should be able to narrow this down to my Hello World UI. And we should be able to see here, look at that one, I'm here. Right, it doesn't matter which instance I hit, this will always be applied. And number two, let me see, and the name is empty. So this is a user error. It's not your application, but the user actually potentially wrote the wrong input, right? And that caused my application to fail. Now, if you're in a production environment, of course, this might not be good for you because you still have hundreds of messages going through. You can actually limit what you want to log. So one of the ways for you to do that is by adding a conditional, right? So when you add a log, you can add a condition here. And this can be an expression. If you have the request ID in scope, you can limit to the request ID, or you can just filter by any of the things that's in scope. Now, somebody did mention debugging, right? If you attach a real debugger, it will stop the world. And somebody will have to stay there and step through the code. And somebody would say this is great for job security because they need you to go through the code all the time, right? But we can do better. With the same debugger that we use in production environment, we can add something called a snapshot. Okay? What this is almost like a breakpoint, except it doesn't stop the world. What you can do then is you can find the code that you want to take a snapshot on. Okay? And I can zoom in here. And I can say, I wonder what's happening on this line of the code. You can just add a snapshot. Okay? And let me just add it, make sure this is actually added. There we go. Now we're waiting for a snapshot to be captured. What that also means is if I go here, let me just make sure I got the view. If I refresh, now there we go. Do you see that? It says snapshot was captured. And now you can get similar information that you're going to get in the debugger, but just in a static form. Okay, this is a snapshot in time. Something went through here, and I can see the code stack. I can see exactly what happened, which calls were made. But more importantly, I can also see the variables that was in scope at that very moment in time. So I can navigate through my objects to see what's going on. I am calling the right endpoint, but I can very clearly see that the name is in fact empty, right? So the reason why this arrow was there and that still doesn't work is because also I kept this thing in the session. If I actually open up a new browser and I go there, well, you can see that this actually works indeed, right? So very, very cool. There are multiple things that Kubernetes offers us out of the box, right? The log, the describe, exec, the pull forward, that allows you to get into your application to see what's happening. And beyond that, you need observability into your architecture. And for that, you should be using some kind of distributed tracer, or you can dump things into the log, and then you can aggregate the log, and then you can correlate them later. Okay? But if all of the things fails, if you really just need to add a new log message to see what happens, or if you want to debug things, then there are additional debugging tools that you can actually add to your application, right? So let me see here. I think my time is almost up. Let me just scroll down a little bit. Just a quick recap. If you want to be able to isolate your traffic, just make sure that you understand how to use labels in Kubernetes. This allows you more flexibility in terms of how you can control the routing of your application. If you have a centralized logger, you can do the search. If you want to get more, you can potentially use BigQuery. One of the things that we also do is that if you output, in this case, your error messages in this context, we can automatically capture errors for you. and do something called error reporting. So what we can do is, if we detected that there's a new error message that we never seen before, we can automatically escalate. We can email you directly. But you can here also see all the different errors that I actually got within my cluster. And here are the frequencies of how often it happened. You can see a distribution of when it actually happened. And you can also add potentially a bug. You can add an issue. You can, if you're using Jira or whatever, you can add an issue to the link. Or if you're like me, I'll just mute it and it's gone. Yeah. Right? So it's pretty useful. With the distributed tracing, you can see your cluster. If you store your data with us, we can build reports for you. So we can actually go back and say, oh, wait a second, you deployed a new version yesterday, and we have the latency from 2 weeks ago before you deployed the new version. We can automatically generate performance regression report. So if you have a huge deviation in terms of performance, we can actually email you automatically. I got them a few reports myself. Okay. So with all that being said, I think that's all the time I have. Just remember there are tools that you can use, and you can find out more in the show notes that has all the links to the tools that I showed today, and also you can learn more and you can see my source code on my GitHub. So thank you very much for your time. Any questions? Yes, question.
Do you know about J command?
J command,
JCMD.
No. Actually, what does that do? And how can I use it?
If you bring your shell in.
Yeah, let me show it.
So you're
I love this. EXEC. Yeah.
Shell.
There we go.
Type in JCMD help.
Help?
Yeah.
Oh, nice.
Okay.
And what it?
So do a JMC -L.
JMC -L. Nice, I love this. Now you are in the shell, as you can see, it's pretty powerful.
Okay.
Oh.
So your average is there. So
Yeah.
it's process 1.
Yeah.
Then you do a JMC 1.
Help. So this will let me troubleshoot this particular instance.
Right. And you see that thread print there?
Thread print where?
Okay.
Yeah.
Okay. So if you do a JMC V1, the thread print is then
Oh, I love it.
done.
I like this.
So
this is another reason why you should be able to shell into it.
So the J command is self-describing, but if you do a J command 1 help command,
J command, 1 help, yeah.
you can see all of the things that are actually available for you here. Like, for instance, if you're doing data memory tracking or something like that, stuff like that can be back.
That is really cool.
So try the VM uptime.
Wait. So before I try that, I'm going to show you something else.
Okay.
Here, you can also specify whichever command line that you want to run, right? So I can just run J command directly, potentially from here.
Yeah.
Give it 1, and then which one did you want to see?
VM uptime.
VM uptime, yeah. So rather than going to the shell directly, I can just issue the command, and this should actually just, there you go. It was up for
An easier way to get the command line?
Yeah.
VM.command line.
where?
VM.command line.
Command line. And, what happened? Dash.
Yeah, actually, that was not
Is it dash or underscore? Yeah. But if
But you can also find the properties, configurations, everything like that.
I love it. Yeah, that's pretty cool. Now with the exec, you can do all of these things very easily for just one of the instances. That's very good tip. I'm gonna have to include this in my next talk. Yeah. Any other questions? Yeah, there's usually a question about the performance about this debugging agent. Yeah, and
That's using like an async call.
it's a JVTI with I don't know how they've done it behind the scenes. To be honest, it has to be async. Yeah. But the source code of this agent is actually online, so you can actually go and take a look. But we do run the same agent in production environment within Google as well. So this is heavily battle tested. One of the other things that people frequently ask is about, sorry, did I just miss out one for you? When you write that expression, right? If I go back to debugger, this is what you can do. I can also open this up in IntelliJ. We actually have a plugin that you can use to attach the debugger to the service that's running remotely. This is pretty cool. But, huh?
Like triggers?
Yeah, something like that. So I'll show you that. So if I go in here, if I go to my application, let me just open this up. Open .xml. This should open up my project. Come on, IntelliJ, you can do this. Come on. Almost there. And I'm gonna get out here in a second. Okay. So from IntelliJ, you can install the Google Cloud plugin. And if you do it that way, you can see that there's a debugger that you can use. And if I go into my application, somewhere once this initializes, it's indexing, so it's a little slow. Once it initializes, you can click on this debugger icon, and then you can attach the debugger to a remote running instance. One thing I really want to show you is the expression in the conditions.
I'm trying to find solution or read time. Why is running?
Yeah, while it's running, yeah. This is debugger that's running, yeah, exactly.
You're done, you can show.
Yeah, there we go. Oh, come on now. Now it's processing some of the, yeah, there we go. So I can debug my application right now. If my internet everything's working, come on. And there we go.
Okay.
Yeah, I need to log in. I should be logging. It's checking my OAuth credentials and all that. It's on this internet, it's a little slow.
So this is a Google plugin for
Yeah, exactly. Yeah. But one thing that's very important is when you do attach the debugging, you're able to actually set expressions. When you output things, you can also use expressions to say, you can call getters and setters. Now, you don't want to call setters, because if you just add this line of code into your production environment, you're modifying the variables, you're modifying the state, and nobody will actually know what happened. So our agent actually makes sure that whatever expression you're going to make does not update the state of your application. So if the method you're trying to call updates the state, the code will actually fail. So that's actually quite nice. Okay. So anyways, that's all the time I have, and thank you very much for your time.